Earth and Venus drift around the Sun on neighboring paths. Placed side by side, they seem almost designed to invite comparison. Venus is only slightly smaller than Earth. Its mass is similar. Its rocky composition is similar. For a long time, it appeared reasonable to imagine the two worlds as variations of the same planetary story. From a distance, that expectation feels natural. Then the clouds part. Not literally. Venus does not easily reveal itself. A permanent blanket of bright cloud hides the surface from ordinary view. But radar maps and spacecraft measurements have allowed us to see what waits beneath. The result is unsettling. The ground is hot enough to melt lead. The atmosphere is crushing. Rain never reaches the surface. Rivers do not cut through the landscape. Oceans do not reflect sunlight back into space. Earth's twin became Earth's opposite. And hidden inside that contradiction is a missing object. An ocean. Or perhaps many oceans. The difficulty is that nobody witnessed the disappearance. There is no ancient shoreline preserved for cameras, no fossil record, no observer standing on a vanished coast. Everything that happened belongs to a past concealed beneath billions of years of planetary change. So the investigation begins where many missing person cases begin. Not with the missing thing itself, with whatever traces survived. Modern Venus appears to offer a simple explanation. Look at the planet today, and the answer seems obvious. It is too hot. Liquid water cannot remain stable on the surface. Any ocean placed there would quickly evaporate. That explanation feels complete. Perhaps Venus was always this way. Perhaps Earth and Venus only looked similar from the outside. The present planet seems to support the idea. Everywhere scientists looked, they found dryness, heat, an atmosphere dominated by carbon dioxide, nothing resembling a blue world covered by seas. For a time, the mystery appeared smaller than it first seemed. Maybe there was no missing ocean. Maybe there had never been one. Yet some of the surviving evidence refused to cooperate. High above the clouds, instruments studying the atmosphere found an unusual chemical fingerprint. Hydrogen. Or more precisely, a particular relationship between different forms of hydrogen. On Earth, ordinary hydrogen vastly outnumbers a heavier version known as deuterium. On Venus, that balance looks different. The atmosphere contains far more deuterium than expected. At first glance, the measurement seems insignificant. Nothing about it resembles an ocean. But the ratio behaves like a clue left behind at a crime scene. Lighter hydrogen escapes into space more easily than heavier deuterium. If enormous amounts of hydrogen disappear over long periods of time, the heavier form becomes increasingly concentrated among what remains. Something had removed hydrogen from Venus. A great deal of it. The question was where that hydrogen had come from. One possibility immediately stood out. Water. A water molecule is built from hydrogen and oxygen. Break enough water apart, allow hydrogen to escape into space, and a planetary atmosphere may begin carrying exactly the sort of fingerprint Venus displays today. The missing ocean reappears for the first time. Not as water, as evidence. Picture sunlight striking the upper atmosphere. Water molecules separate. Hydrogen drifts upward. Some of it escapes the planet entirely, disappearing into space one atom at a time. The process is invisible from the surface, yet its signature remains. Suddenly, the simple explanation begins to weaken. If Venus was always dry, why does one of the driest worlds in the solar system carry evidence that resembles water loss? The clue does not solve the mystery. It enlarges it. Because a fingerprint cannot tell investigators how large the missing object was, a cup of water and an ocean can both leave traces. Scientists began constructing competing histories. In some reconstructions, Venus possessed shallow bodies of water that survived briefly before disappearing. In others, substantial oceans persisted for much longer periods. Computer models produced different timelines, different climate pathways, different moments when the planet may have crossed a critical threshold. The surface remained hidden beneath clouds. The past remained hidden beneath uncertainty. Several explanations could account for parts of the evidence. None explained everything perfectly. That uncertainty created a new problem. The original assumption was still attractive. Venus receives more sunlight than Earth. Perhaps that alone determined its fate from the beginning. Yet, as additional studies accumulated, the idea of permanent, unchanging dryness became harder to maintain. The atmosphere continued pointing backward toward lost hydrogen. Climate simulations demonstrated ways liquid water might survive under certain early conditions. The evidence never assembled into a direct photograph of an ancient ocean, but it began behaving as though something significant had once been there. The old explanation encountered a contradiction. If Venus had always been fundamentally the same planet we see today, some of these clues should not exist. The investigation was no longer asking whether Venus is dry. That question had been answered long ago. The investigation had shifted to something far more difficult. When did the dryness emerge? What transformed the planet? The modern world beneath the clouds started to look less like an original condition and more like the end result of a process. A transformation. A history. A planetary climate evolving over immense stretches of time until a threshold was crossed and recovery became impossible. Exactly where that threshold lies remains uncertain. Exactly how much water disappeared remains uncertain. But the meaning of Venus has changed. At the beginning of the story, Venus appears to be Earth's twin. Then it appears to be a failed version of Earth. Eventually, it becomes something else entirely. A record. A world preserving fragments of its own lost past. And so the final image returns to where the mystery began. Two planets orbiting the same star, nearly identical in size. One blue with oceans visible from space. The other hidden beneath bright clouds. The difference no longer looks inevitable. The clouds of Venus may conceal more than a hostile surface. They may conceal the history of a world that changed. A world where the missing ocean matters because it suggests that planetary destinies are not always written at birth. Sometimes they emerge from fragile pathways, followed for millions of years, until two similar worlds no longer resemble one another at all.